I know. I'm still working on it, okay? No, I have not done the 100 subscriber special yet. I'm sorry. I'll get it done. Spring break, I promise. I'll do it spring break.
Just be a week and go home.
We got
No, I want a pizza party.
A pizza party.
Yeah.
Something worth.
Okay, I got like 115, so I won't,
I would.
You're gonna go on a campaign against it? All right, so welcome back, everybody. So again, number one is an easy type. I'm just gonna redo this one. We already did it in class because I forgot to do the video, but we just do -2 and -2 to get +4, and then -2 plus -2 to get -4. So x minus 2 should be my answer. All right. So let's take a look at number 3. Now, we've already talked about how that's a hard type problem, and we can differentiate the easy type to the hard type by saying, well, there's a number out front. That's why it's a hard type problem. So 9x squared minus 12x plus 4. I know the 9 sitting out front makes this a hard type. So I take 9 times 4. What do I get? 36. Are there factors of 36 that add to get to -12? -6, -6. -6 times -6. -6 times -6. So now I rewrite my middle term. First term stays the same. Middle two terms get broken up into -6x and -6x. 4 stays the same. This gets rewritten here and here. And now we underline first two, underline last two. We factor by GCF. What's the GCF of my first set? 3x. 3x. Write it out. That gets me a 3x minus 2. Okay, what's the GCF of my second set? What's that? -2. And I'm glad he said -2. How do I know that my GCF is negative? Somebody else tell me. Liam?
There's the middle, like the negative and the x's.
Right there. That term tells me that my GCF is negative. So I pull out the -2, and that will divide out. So now I get a positive 3x. Positive 4 divided by -2 is a -2. And look at that. Inside the parentheses match. That's one of my 2 solutions. The other one is the stuff that's left over, the other factor. Was that new? No. Okay. Yeah. Yes, that would be fine. If you wanted to write it as 3x minus 2 squared, that's perfectly fine. All right, so none of that was new. Let's go back to our warm-up here. This is pretty much the only new stuff here. This difference of squares. Now, there's 2 sets of criteria to be a difference of squares. What's the first one?
They have to be, it has to be a minus sign.
Good, it has to be a minus sign. The name implies a difference of squares, right? So it's got to be a subtraction. What's the other condition? It's got to be a subtraction, and then what do they all have to be? All perfect squares. How do you know when a variable is a perfect square? Oh.
If the exponent is an even number.
Good. The exponent is even. And then a lot of people are struggling with, well, I don't know what numbers are perfect squares. Well, you have those little devices that, calculate things for you. Just plug it in your calculator. Oh, I don't know if 16 is a perfect square. Oh, it is. I mean, should you guys know up to 10 perfect squares? Yeah. 1, 4, 9, 16, 25, 36, all the way up to 100. Okay? So I look for, is it a difference? And are they all perfect squares? So let's check number 9. Because that's the only thing that we would be able to do with a 2-term polynomial, with a binomial. First off, is it a difference? Is s squared a perfect square? Is 16. So now I know that this is a difference of squares. We go to our parentheses. put a minus and a plus, or a plus and a minus, doesn't matter. And then we square root everything. Square root of s squared is just an s. Square root of 16 is 4. And there's my answer. That's the only new thing that we did yesterday. That's it. Okay. No, don't put them. Take a look at 13 now. First off, I guess I should have checked what right off the bat? If there was a GCF. I mean, I should have checked that in all of them. Have I had a GCF in anything above 14 yet so far? No. So there's no GCF for 13 either. Okay, good. So now I check to see if this is a difference of squares. Okay, is there a minus sign?
Yeah.
Good. First box, checked. Second box, are they all perfect squares? Yes. Even the x to the 6? Yes, because it's divisible by 2. The power is divisible by 2. Now remember that taking a perfect square is not the same thing as dividing by 2. For some reason that got in our brains somewhere along the line, and I've had a lot of people telling me that taking a square root is like dividing it by 2. That's not the same thing. I'm talking about the exponent when I divide it by 2. When I'm looking at a whole number like 9, you actually have to perform the square root. The square root is an operation that figures out, like if I'm looking at 9, I got to figure out what number multiplies by itself. What can I fill in the blank with? The same, and it's got to be the same thing to get to 9, right? So it's got to be 3 times 3. Right? I'm looking, that's a square root, okay? Not dividing it by 2. All right, so I know that this is a perfect, or a difference of squares, so I can go to my parentheses, 1 minus, 1 plus. Again, order doesn't matter there. And I can say x to the 3rd and 3. And there's my answer. Questions about that? Okay, now the last one. What should I check first? Is there a GCF? Yeah. That's why I added this one in, because that was the only other kind of like new-ish thing that we did, even though we did that in section 8 too. This is all divisible by 3, so let's remove it. So this is x squared plus 6x plus 7. Sweet, it turned it from a hard type to an easy type. Okay, what factors of 7 add together to get 6? Nate? Well, what is 7 times -1? Negative 7, not positive 7. So 7 and -1 won't work. None of them. But it's not necessarily prime. We don't write prime. We don't write not factorable. We just write that with the GCF pulled out. Okay? Remember, on the homework, I'm going to tell you how many are not factorable. Like oh, that's actually not right. That's the wrong homework assignment there. What? It's a worksheet instead of a book page. But I'll tell you, factoring worksheet. Factoring worksheet. But I will tell you how many are prime. Okay, I will tell you how many are prime or how many are not factorable. I'll have to glance at the worksheet to see. All right, questions there. Anything else on the warm-up? Okay, take out your homework. I've got the key up on the board here. We're going to go through. If you've got any questions, if you want to go over any, by all means, ask. But I've got the key up on the board. There's 14 and 15. So 14, my answer should have been 2x minus 1. 2x minus 1. Or if you want 2x minus 1 squared. $15 is not factorable. That's one of the ones that's not factorable. Scroll down here. Oops. There's 16 and 17. 16 is a 6x minus 1. 6x minus 1. 17, not factorable. Look at the list there. Multiplies to get you 100, adds to get you 10. Nothing works. You might be tempted to say 10 and 10, but that's 20, not 10. Okay, here's 18 and 19. Yeah, we should have done it this way. Take a look down here. That's the way that I would have done this problem. Pull out the GCF first. The GCF is 9. You remove it, you get an x squared plus 2x plus 1, which is an easy factor. Factors of 1 that add to get to 1. 1 and 1. Oh, sorry, factors of 1 that add to get to 2. Excuse me. 1 and 1. Taking a look at 19 there. You're looking for factors of 400 that add to get to negative 40. That's negative 20 and negative 20. So it should have been 4x minus 5, 4x minus 5. Okay, questions, anything through 19 so far? Want to go over anything through 19? Okay, here is 21 and 22, 23 and 24. Here starts the new stuff. Guys, don't be confused when it has a number squared. I'm not really going to give you any ones like that. It's just kind of like trying to lead you in the direction of knowing that it's a perfect square. But I think sometimes squaring the number just kind of confuses you guys a little bit. So like in 25 down there, I wish it would have just said 81. But number 21, that is a difference of squares. So it's 1 minus 2x, 1 plus 2x. 22, same thing. That's 5m plus 4n, 5m minus 4n. 23 is another one of the ones that are not factorable because this is, well, x and y are not even powers. They're odd powers. They're powers of 1. 24 is a difference of squares. 7p to the 6 plus 3q to the third, 7p to the 6 minus 3q to the third. You don't need to show the second step in there. I'm okay if you just go straight to your answer. Okay, there's 25, 26. Then we can start to see 30 and 31 at the bottom. 25, again, I wish it would have just said 81, not to try to confuse you with that 9 squared. But it should have been 9 plus 10x squared, 9 minus 10x squared. Number 26 is another one of those not factorable ones because they're not even powers. X to the third minus y to the third. Then we got the last set. 30 is x minus 4, x minus 4. 31 is a difference of squares. 10 plus 9y, 10 minus. Sorry, 10x plus 9y, 10x minus 9y. Scrolling down a little bit more here, here's 32 and 33. 32, you got to pull out your GCF of 4 before you work with the inner polynomial, the inner trinomial. You pull out the 4, you get a 9x squared plus 6x plus 1, which factors into 3 and 3. 9x squared plus 6x plus 1 factors into 3 and 3. So you get 4 and then 3x plus 1, 3x plus 1. Guys, make sure that 4 does not kind of vanish into thin air. You got to keep your GCF there out front. That's why I always say arrow it down. Number 33, that is a difference of squares. Subtraction sign, even powers, all perfect squares. Here's 34 and 35. 34, unfortunately, there's no GCF to pull out, so the number just gets really big. It's 1225, but fortunately for us, negative 35 and negative 35, when we square root it, that works. So therefore, I can factor it using negative 35, negative 35. And then there's 35, x to the 7th plus 12, x to the 7th minus 12. Okay, I want everybody to pull out a separate sheet of notebook paper. Because now we know how to factor anything that, well, I shouldn't say anything. We know how to factor in a variety of different methods, okay? The problem is we don't necessarily know what to do when, okay? We don't necessarily know what to do given certain problems. So I am going to create for us a flowchart of what to do. Okay, everybody writes, I guess, what should you always check right at the very beginning? GCF. I should always check for a GCF. Okay? So we're going to write that big at the top. Always check for a GCF first. If you want to title this factoring, whatever, I don't know, factoring flowchart. I am going to rewrite this pretty much every day up until the test. We're going to go over this flowchart every single day before the test. So we've got a GCF. You always check for a GCF first. Then everything is determined by how many terms you have. Okay? Whether it's 2 terms, 3 terms, or 4 terms. We don't know how to factor anything use it with a 5-term polynomial. We don't know how to do that. Okay? But we do know what to do with a 2-term. We do know what to do with a 3-term. And we do know what to do with a 4-term. I don't know, I off-centered that a little bit. That's okay. Well, I've been asking this all along. How do we factor something that has 4 terms? Factor by grouping. Is there any other method? No. The only thing that I'm able to do with factoring a 4-term is grouping. Okay? That's the only possibility of factoring something with a 4-term polynomial, is grouping, as of right now. Now, 2 terms. We just learned what to do. What's the only thing? What's that called that we learned yesterday when it's a 2-term? Square, kind of. Starts with a D. Difference of squares. Put those both together. Difference of squares. Difference of squares. This is the only thing that we could possibly do. Difference of squares. And remember, we have to check our 2 criteria for that, right? We have to check, is it a difference? And are they all perfect squares? Difference of squares. Now, the 3 terms is what it can get a little iffy. Well, there's 2 different possibilities with 3 terms. The first part is the easy type, what I have been calling the easy type, where it looks like x squared plus bx plus c. I'm putting b and c in there so that we know that there's no number out in front of x squared. That's the one where we could go just straight to our answer, straight to our 2 parentheses. The hard type, well, that's the one where we have the number out front, or what we might say as an ax squared plus bx plus c. Making note of the number out front. What did I call that method? Factor by, anybody remember? Factor by rewrite, yeah. Some people call that the master product method. I like to call it factor by rewrite. Again, that's Mr. Laverick terminology, not formal. Factor by rewrite. Rewrite the middle term. So if you follow this flowchart, Okay? If you follow that flow chart, that'll tell you exactly what to do when. You always start with the GCF, and then at that point you decide whether it's 2 terms, 3 terms, or 4 terms. If it's 2 terms, you check for a difference of squares. If it's not a difference of squares, then you're done. If it is, then you put it into your 2 parentheses. If it's a 3 term, after you check for a GCF, you determine whether it's an easy type or hard type. You know how to determine whether it's not factorable, given an easy type or hard type. If it's 4 terms, after you check for a GCF, the only possible thing is to group the first 2 and last 2 and see if it's factorable by grouping. If it's not, then it's not factorable. Okay. So I'm gonna reference this a lot. Okay, so it might be a good idea to keep that sheet of paper somewhere within your notebook. Okay, keep that sheet of paper because I'm gonna reference back to that a lot. So I want to give you some time, giving you about 13 minutes to work on your homework.
No.
All right, so go ahead and get to work. So long, everybody watching at home.